Welcome to our channel. As earlier, we completed the LangChain components like LLM prompts, memory, tools, and today we are at the vector DB, or known as RAG. We are going to start with the RAG today. Actually, RAG is nothing but the retrieval-augmented generation. And before going to know what is RAG, we need to know why we use the RAG in real world. When you, for example, when you use ChatGPT, then you will ask the ChatGPT about the private organizations data or else private data from the others, like some sort of PDFs or CSV or Excel files. It won't be the response because of the it don't trained on the private data and it don't have the access to the private data of the companies. So we don't get the information about the private or the secured information of the companies. So for that they introduce a RAG. And one more thing to know is actually LLM models are not up to date. They have certain time, like models will work accurately for some time. Like if you take some other models I've shown in the previous videos, it is up to date of 2022 or 2023, like this. That is also one disadvantage of the LLM. So to eradicate those, they introduce the RAG. RAG is nothing but a retrieval augmented generation. And today in this RAG, we are going to learn about the document loader and document ingestion. And document loader is nothing but the loading the documents, and document ingestion is nothing but the splitting the text and creating embeddings, storing in the DB and retrieving from the DB. It is all about the document ingestion. And we go with this workflow to know easily. In the end, I will conclude how the RAG is working and getting into the documents. Initially, we have some documents. We will take those documents and we will load into the using loaders. We have a lot of loaders like PDF for the PDF loader, CSV for the .csv folders. Like we have some more. I will explain that. And whatever the content we load into the from the documents, we will split the text into the chunks. Like we create the chunks like large data broken into the small chunks, and we creating the embeddings to the chunks like a numerical vector representation. Then we will store in the database like vector stores. It is the concept of vector DB. And then we have the retrievers to retrieve from the DB, and we will integrate the LLM response to this retriever. And it is all about the RAG. Like we will retrieve the content. Up to here we will retrieve the content. Then we will argument with the generation. Like generation is nothing but the LLM response. We will including the LLM response. Like if you got the summary, like from the PDF you need the summarization of whole PDF. Then you give to the PDF to the document like a loader. Then you split the text, whole content of the document, and you create embeddings and store in the database, and you can retrieve. Whatever you retrieve, you can summarize those retrieved content and generate the new text. It is called the generation. And you integrating this retrieval and generation is nothing but the RAG. It is about the RAG. And getting into the document loader, initially for our example, we using the PDF loader, and I'm using the document LangChain community.document loaders to import the PYPF loader. It is a PDF loader, and they are the how agents are used. It is a research paper I used, which is about the how AI agents are used, evidence from the 1,77,000 NCP tools. And we have the introduction, background, data, methodology, results, description, conclusion, work process. It's all about the research paper about the how AI agents are used. And I'm loading the content. I'm loading the first 3 pages, and those data is as output here, like document metadata, which has the producer and some sort of creation date, author, DOI keywords, and mod date, modified date, title, and the source. And here the page 1, page 2, page 3 with the page labels 1, 2, 3, and the content about the each page. And I'm loading the first page of content. It's all about the first page content. It contains up to the introduction. Like we loaded these up to here. We loaded as a page 1, and it is the content of page 1. And it is all about the PYPDF loaders. And then we have the another loader from the community, LangChain community document loaders, text loaders. Text loader we are retrieving this document like somewhat I given in the file, like what is a how take a evolve. and I will load the text loader using text loader, and we get the metadata about the source and nose page content. We got the, and I retrieve from here same content whatever we given in the notes.ts, that is retrieved from the text file. And another major one is a YouTube loader. The YouTube loader is used to load the video and transcribe the video. It gives the text format, and the video link is the previous video of mine, and it is about the YouTube loader from YouTube URL. And this is my video content. Like, hi everyone, welcome to our channel. Earlier we discussed about the LangChain components such as LLM models, chain prompt, and today we are going with another interesting component called memory. And a lot of people have doubt like how the ChatGPT or other models store the messages. This is all about the transcript of my YouTube video, and it's nearly 25 minutes, I guess. And now we have completed about the document loader, and I will show the types of document loaders also afterwards. And we will getting into the document injection. First, we will complete this example, and I will show some sort of things like what are the text splitters, what are the retrievers, and what are the embeddings, types of vector DBs. We will go with that with the official website. And in the data injection, first part is like here we have completed the documents and document loaders. These two belongs to the document loaders. Then from the text splitter, like I will show, these two are related to document loaders, and from here to here, these are related to the document injection, and including the LLMs response. And initially we have the text splitter. It breaks the large documents into smaller chunks because of we have the limitation of tokens. In the models we face a limitation of tokens. To eradicate that, we use small windows like large documents into smaller chunks, and we will use whatever content we need, not the whole page. If I need only one page and I need this page content summarization, then I will use this for first page as a summarization. Like here, just I will pass /1 first page summarization. I will get that, or else I will give like this. It is all about the splitting. Actually, I split the whole content. And getting into the recursive text splitter, it is a type of text splitter. We have the recursive character text splitter. It contains the properties like chunk size and chunk overlaps. Chunk size is nothing but the maximum characters per chunk, and overlap between the chunk. And getting into the separators, I will explain the separators. And it is all about the paragraph, slash and slash n. Slash n is nothing but the new line, and paragraph, new line, and end of the sentence, end of the words. Like we have the between the words we have the spaces, and we are separating those words and the letters. It is all about the separators, and we are splitting from using the recursive character text splitter dot split documents. I'm using the object and calling the method called text split documents. Like it split the documents, and we got the metadata of the document and the page content. Just I'm printing the docs, the splitted docs, and it is the first page content. I'm getting into the embedding models. Embedding models is nothing but it converts the raw text into the vectorization, like numerical representation of vectors. And here we're using the coherent embeddings with the model embed English v3.0. And we will see the transform raw text such as sentence, paragraph, or tweet into the pixel length vector of numbers that capture its semantic meaning. It's nothing but we'll create the matrices or vectors, and we will fetch from that semantic meaning, captures its semantic meaning, nothing but. And after text splitting, we have the embeddings. Embeddings is nothing but the converting raw text into the vector of numerical representation of vectors, and it is we have the pixel length vectors. Here we're using the coherent embeddings with the model embed English v3, and we have a lot of embedding types. Like whatever the LLM models is there, they will provide the embeddings also. For example, Gemini embeddings. We have the OpenAI. Korea we are using, like Cloud also we have. Some sort of the LLMs have Hugging Face. Sorry, we have the Hugging Face also. Then we will store those embeddings in the vector DB, and we are not created the embeddings for the document. Just we initialize the model, and here we are storing the embeddings into the vector DB. DB nothing but the database. We are storing in the data store, and for the storing we are using the Chroma as a vector store. In the vector, we have the lot of types in the vector stores. One is a Chroma. We have 5 or 6 fine code and lot of that. I will explain those. And from documents, like I'm storing using Chroma from documents, docs, and embeddings. It creates the document and keeping relation with the documents and embeddings, and it creates embeddings to the documents and stored in the database called DB. DB is our database. And then I'm returning from the documents, like DB as retriever. Retriever is a method to retrieve the content, and we are using the keywords called such type and such keywords. Like such type is a similarity, and keywords is the keyword is a top three, like k equals to 3, like top k. And in this, if you ask the what are the MCP tools we used in the PDF, then it gives it goes all the PDF and it gives a similar top three similarity with the whatever your question answer, like whatever you query right, based on query, it gives a top three similar response and pick up one best one. It is about the retrievers work, and I'm initialize the LLM model and given the template like you are the expert assistant for summarizing the academic or legal document, something I've given. But just think as a document, and I given the docs as a document chain. It is nothing but the providing the context to the prompt, and I given the instructions to the LLM like extract and summarize the followings: problem statement, proposed method, key findings. Return the summary in the JSON format with the problem statement, proposed method, and key findings. And I given those template to the prompt template, and I form the chain with the prompt LLM and state output parser, and summarizing and calling the invoking the chain using the docs like document, old document, and it giving the summary of the document. Like in the format of JSON, we got the first one is the problem statement. There's a lack of understanding about how AI agents are currently being used, particularly in terms of data and potential risk. It is about the problem statement, and we got the key findings. Before that, we got the proposed method. The paper proposes analyzes a 177,436 AI agents tools created from 11/2024 to 2026 by monitoring public MCP servers repositories. These tools are categorized based on their direct impact, perspection, reasoning, and actions, are mapped to the task domains using standard. The study tracks tools usage over time, focusing on the shift from perfection to action tools and access the consequency of tasks using ONET occupancy. It is the methodology proposed in the research paper. It is given all about the research paper methodology. And some of the key findings we got from the paper is the tool ecosystem, usage trend, AI co-authorship, and this implication. And it is a type of project like we are creating the summarization project like PDF summarization. Instead of reading 36 pages of PDF, you can go with this summarization like whatever you need from the research paper. Like you can ask the research paper, I need what the problem statement is and what are the method proposed in the research paper and the key findings. Then it will give the whole answer. And here we use the match tokens as a 50, so it given in the shorter way. If you need more, you can give more. Like if you give them tokens more, if it generates more, you can use as usual. And it is a research paper summarizer as an agent. We can use as an agent, and it is our example paper summarization. We'll go with the like I will explain this. Initially, we retrieve the content up to here retriever. Like we retrieve the content up to here using the retriever similarity search, and then we use the LLM response as we taken the model, initialize the model, and given the template. Then we invoking the chain to summarize the whole PDF. It is all about the LLM response, and we will go with the official documentation of document loaders and some document injections. Getting into the document loaders, we have the two types of loaders. Like initially we have used in the first one, loader.load. Yeah, here py-pdf loader.load. We have the two types of loaders. One is the loads and lazy load. Load the all document at once, and lazy load is strings document lazy, usually for the large injections. And we have the lot of loaders, and it is example of CSV loader. Loaders are categorized. And some categories are web page. One is a web page. We will give the web unstructured recursive URL, and second one is the PDF. We are loading PDF number, PDF, like something. We have the lot of things you can go through, and some cloud providers and social platforms like Twitter, Reddit, and the messaging services like Telegram, WhatsApp. They are all the loaders and productivity tools. And these are the common file types, whatever you use. CSV loader, JSON loader, text loader, HTML loader, and these are the things. And these all are the document loaders. You can see in the official website. You can see the text splitters, vector stores, embeddings, retrievers. These all are from the official website, like official documentation only. And you can find a lot of things. I explained about the only single retriever and single text splitter and one embedding models and one vector store. In the vector, we have a lot of vector stores like Chroma, Fiasys, Pinecone, etc. But in our example, we use the Chroma. You can go with the official documentation and you can search for the lot of vector stores. You can find it. I will provide the link of documentation in our video description. Thank you for watching. Keep supporting. Please like the video and subscribe to my channel. Bye bye.